Okay, hello. This will be the third video for joining the FRC code team. Previous video was a top-down organizational structure of what all of the code and how it interacts with each other. This time we're going to be going over the organization style. So the important thing is in the previous code, all you saw was the swerve drive, and the swerve drive is still here. But on top of the swerve drive, we have about five different subsystems that are organized in a very similar way to the storage drive that have their own little kinks in them. So the important thing to note is for every subsystem, you're going to need to make a subsystem.java, or for in this example, let's take the claw. Our claw from last year was the state. You need to configure the SparkMax. So these will be the SparkMax configurations in the subsystem. These are the actual. This is where you actually configure the SparkMaxes that are on the actual robot. Make sure they have the proper voltage, and then how they move is with these functions right here. So follow a pretty similar structure to this, like this. You want to name all of your variables in the beginning, make your constructor, and then configure inside that constructor the SparkMax. Have your two methods, which will be move and stop. And then in your periodic, you always want to put the diagnostic variables just to make sure that we know exactly everything's doing exactly what it's supposed to be doing. And just to show you another example, it's set up the exact same way. You have your variables, config, and then encoders and any other methods, and then your periodic. This is the most important one here. Afterwards, you go to subsystem commands here. Let's go back to the claw. This will be where you do your execution commands. So this will be the link between the robot container and the actual subsystem to make sure that things are actually moving. And then we may or may not have methods, and these methods are going to be variable methods that are going to do certain things on the robot. So it might be move the elevator up 10 inches, right? If we take the elevator is a pretty good one. While this is a if statement that just makes sure that the robot height is either at 0 or goes up to a certain position if pressed by a button. So that's what we will do our methods. In terms of organization of the robot container, you always want to have, so again, all of your variables are in the center. It's like you're writing Java code. And you want to do all of your constraints, and then you want to do your configure bindings, and then lastly, set up your autonomous command. The important thing afterwards is with your autom commands, with your path planner. So when doing path planner, the important thing from just an organizational structure is this is the example right here. So if you have your autonomous, which is, let's say we're going to the mid-ref auto, this is from last year, you want to set up each one to be in a different sequential group. So I have three different paths, one to the reef, from the reef to a point, and then back to the starting position. In total, these three paths combine together, but they are separate. And I'm going to be putting a swerve stop in between them to make sure that I'll know I can test each one individually and then go from there. That's just setting up everything in your code. That should be it.